when you have to simplify a derivative, okay? Because we're confronted with this function and it says show that the derivative is this. So that means there is some simplification that we need to do. So let's get straight into it and then we'll answer part B as well. So if we have to use the quotient rule, we can recognise that because we have a function at the top and a function at the bottom. So u is going to be 2x to the half and v is going to be 1 take x. Alright, u dash, I'm going to do it slowly and then I'll simplify it. So it's going to be 2 times half x to the minus half. Alright, 2 times half simplifies to just x to the minus half, doesn't it? And then v dash, 1 take x just becomes minus 1. And I think it's important that we keep it as minus 1 because that's going to have an impact. The negative is going to have an impact. Okay, let's put it all together for dy on dx. It's going to be u dash v. I'll leave it like this for now. X to the minus half times 1 take x. U dash v, take away uv dash. And that's all on top of v squared. Okay, so that's what we've got if we're to differentiate it just using the quotient rule without simplifying. And so I'm looking at that and I'm going, I want to get it to here and I'm going, what are some similarities? Well, there's the 1 take x squared. Okay, so I'm not going to expand that, I'm not going to try and simplify that. That's staying right there as it is. Instead, what we've got to do, we've got to express our negative powers at the bottom of a fraction and our powers of halves as square roots. So let's go through and do that. This term will become 1 take x on the square root of x. That's what that is. Okay? This term will become, we've got minus and minus, so that's going to become plus, and it's 2 times the square root of x. Okay? And that whole thing is on top of 1 take x squared. Okay, what we need to do next is we need to collect these together. We want to add them together. So before we can add them, they need the same denominator. So we've got a denominator of root x here, which means we're going to multiply this one by root x on root x. We're multiplying by 1, not changing its value, that's fine. Okay, so then let's write up here what we have next. We'll have 1 take x on root x. Okay, that's that term. Plus, we've got 2 root x times root x. All right, whenever we have a number times a fraction, it always goes to the top. The other way you can think about it is that every number here is a fraction. It's that on top of 1. So we have the top times the top. Root x times root x is x. So we have 2x at the top, and at the bottom we'll have root x. Okay, all on top of 1 take x squared. Okay, now they have the same denominator, we can bring them together. We've got 1 take x plus 2x on top of root x on top of 1 take x squared, which is on top of 1. Okay, you can see AD on BC. So at the top, 1 take x plus 2x is going to be 1 plus x. And at the bottom, BC, root x becomes 1 take x squared. Okay, that's how we do the show. Alright, so prime example, like here, if it says, don't simplify, full marks there. If it says, show that the derivative is this, that means you need to perform this simplification and manipulation process. Okay, so very clear when you need to process it. Okay, then in the next part, it says, let's answer part B together as well. And this is an important part here, because this could be a little place where we slip up. For what values of x is dy on dx equal to 0? Remember, this is dy on dx. I should put equals here, dy on dx. When is this equal to 0? Okay, that's the first part. When is it equal to 0? Well, it's going to equal 0. This is what we call a rational function. We've got something at the top and something at the bottom. All right, and remember this from year 11. I've put n for numerator and d for denominator. F of x is going to equal 0 when the numerator is 0. All right, because that means we've got 0 divided by whatever's at the bottom, it's going to equal 0. And then it's going to be undefined when the denominator is 0 because we can't divide, we can't divide by 0. That's when we have an asymptote. Okay, so we should remember both of those points from year 11. So looking at this function here, it it's going to be 0. F of x will equal, dy on dx, which is 1 plus x on root x times 1 take x squared. It's going to equal 0 when the numerator is 0, which is minus 1. Okay. Now, that is the solution to this problem. That solution there is the solution to this problem. But it's not a solution on our graph. Can anyone see why? Let's think about our original function and think about this x value. X is minus 1 and this function over here. What happens when we put x is minus 1 into this function?
It can't be in a root.
Yes, because we've got the square root of minus 1. Alright, and so that means it actually doesn't exist. The function doesn't exist when x is minus 1. And so that means, although this is a solution to this, it's not a solution that's on the function. And so, even though we've processed it and we've done the right mathematics, we need to consider this solution in the context of the whole problem. Okay, so that's quite hard. We need to think about this solution, say, is this a justified solution? And so what that means, this is the only solution where it could be, and even that's not a solution, because it doesn't apply in the context of the problem. So therefore, dy on dx is never 0. It does not equal 0 for any values of x. Okay? So that's part I. Then part I says, well, what about when is it undefined? When is dy on dx undefined? Okay, so algebraically, if we're thinking about it, we're going, well, that's when the denominator is 0. That's when root x times 1 take x squared equals 0. So let's go and process this. We'll use the null factor law. We'll have root x is 0, or okay, x is 0 or x is 1. If you put x is 0 into the slope equation, you're going to get dividing by 0, it's going to be undefined. And if you put 1 in, you're going to have 1 take 1, that part will be 0, the whole thing will be 0. It's going to be undefined as well. So that's correct, but there's something else we need to consider as well. Again, we need to think about the context of the problem. And we can think about it just in terms of the slope function here, okay, or we can think about it in terms of the original function. So the slope function, it's undefined when x is 0 and when x is 1. When else is it undefined? If we're looking at that, when else does it not exist? It can't exist for negative values because there's a square root here. Because of this square root here in the slope function and in the original function, it does not exist for values that are negative, for values less than 0. So we've got these three statements. X equals 0 or x is 1 from that process there. And then we need to think about this one because of the context of the problem. It's not a solution that we generate from a process. Okay, that's one that we get from answering the problem. And we can synthesize those two. Alright, x equals 0 and x is less than 0. That's x is less than or equal to 0. Or x equals 1. Okay, so that's how we're going to answer part 2. Alright, so both questions 6 and 7 are quite similar to this. They get you to think about those kinds of things. They're quite good in that regard. Alright, so they're show, and then finding when is it 0, when is it undefined, and getting you to think about the function. Very good. Alright, so we'll keep going with whatever you're up to. Yes?